The #1 selling product of its kind with over 20 years of research and innovation. Botox Cosmetic, out of botulinum toxin A, is a prescription medicine used to temporarily make moderate to severe frown lines, crow's feet, and forehead lines look better in adults.
Effects of Botox Cosmetic may spread hours to weeks after injection, causing serious symptoms. Alert your doctor right away as difficulty swallowing, speaking, breathing, eye problems, or muscle weakness may be a sign of a life-threatening condition. Patients with these conditions before injection are at highest risk. Don't receive Botox Cosmetic if you have a skin infection. Side effects may include allergic reactions, injection site pain, headache, eyebrow and eyelid drooping, and eyelid swelling. Allergic reactions can include rash, welts, asthma symptoms, and dizziness. Tell your doctor about medical history, muscle or nerve conditions including ALS or Lou Gehrig's disease, myasthenia gravis, or Lambert-Eaton syndrome, and medications, including botulinum toxins, as these may increase the risk of serious side effects. For full safety information, visit BotoxCosmetic.com or call 877-351-0300.
See for yourself at BotoxCosmetic.com.
Ryan Reynolds here for, I guess, my 100th Mint commercial. No, don't. I mean, honestly, when I started this, I thought I only have to do like 4 of these. I mean, it's unlimited premium wireless for $15 a month. How are there still people paying 2 or 3 times that much? I'm sorry, I shouldn't be victim blaming here. Give it a try at mintmobile.com/save. Whenever you're ready.
$45 upfront payment equivalent to $15 per month. New customers on first 3-month plan only. Taxes and fees extra. Speed slower above 40 gigabytes. See details.
If you wanted to support me and also listen to every single episode of this podcast ad-free, then you can do so on Patreon, Spotify, or Apple Podcasts. I will link to everything down in the show notes below. And if you wanted to support me for free, you can subscribe on YouTube. Thank you very much, and I hope you enjoy this episode. Hello, and welcome back to 3D Printing Basics. This is episode number 39, and in this week's episode, we are going to be discussing multi-material printing. We are going to talk about what it is, why it may be beneficial for you to use multi-material printing, and some tips and research you can do to make sure you get successful prints out of it. Alright, with that being said, let's get into it. So the first thing I want to discuss is what exactly multi-material printing is, just in case anybody is listening who doesn't know. So what multi-material printing is, it's exactly what it sounds like. It's when you're 3D printing with 2 different materials. Not 2 different colors of the same material, for example, red and green PLA. It's when you're using 2 different materials, for example, if you're using PLA and PETG on the same print. And I'm sure the first question for most people is going to be, why would you ever need multi-material printing? Is it a practical thing to do? And the answer to that is yes. If you can get multi-material printing on your printers to be consistent and to be turning out good quality parts, it can actually be very useful in our day-to-day lives. Some use cases for multi-material 3D printing is water-soluble supports. That's definitely the #1 reason that I would think beginners in the 3D printing space would be looking to use multi-material printing. For those of you that don't know, water-soluble supports is a different type of material that is exactly what it sounds like. It dissolves in water, and it's great to use for complicated parts that you're printing that have a lot of complex supports that would be difficult to remove if you were using just normal PLA supports if you were printing a PLA part. You can use water-soluble supports, and then you just dunk the whole entire part, or you submerge the whole part in warm water, and over the course of, I think, 24 hours, all the water-soluble supports dissolve, leaving you with your finished part. And that is something that's really useful, especially if you're somebody who likes to print, for example, figurines or other parts that are really, really complex and would require a lot of supports to be printed correctly. Water-soluble supports could be very valuable to you because, I don't know about you, but I'm someone who really dislikes taking off all the supports. So water-soluble supports, just dunking a part in water and taking it out in a day and having all the supports be gone, is something that's really appealing to me. This episode is brought to you by PCBWay. If you're into 3D printing, you know how important precision is, and PCBWay delivers that, not only in custom PCB manufacturing, but also in 3D printing services. Whether you need high-quality parts for your next big project, rapid prototyping, or even CNC machining, PCBWay has got you covered. With a wide range of materials and super competitive pricing, they're your go-to for bringing your designs to life. And now you can use my code 3D Printing Squared. Again, that's 3D Printing Squared, SQUARED, to get $10 off your first order. Check them out at PCBWay.com. Again, that's PCBWay.com, and take your projects to the next level. Another use case that actually falls along the same line as the water-soluble supports would be alternate material supports. And the most popular example of that would be printing things with PLA and using PETG supports. It's basically the same concept. If you're printing a super complex part and want to make taking the supports off as easy as possible, then it has been proven that if you're printing a PLA part and you use PETG supports, those PETG supports actually don't stick to the PLA part, and it makes it a lot easier to remove the supports because they just tend to kind of fall off. And that is something that is, again, very useful for the same reasons as the water-soluble supports, just overall making the whole entire process easier when it comes to taking off or removing supports. And the last use case that I want to talk about is basically using TPU with any other material. TPU, as we know, is a flexible filament, and it has been known to be used as sort of kind of like a door hinge. Just something if something needs to be rotated, or if you're printing something that's similar to pliers and you need something that needs to move or flex but not break, TPU is obviously a great answer to that. But if you also need the whole entire thing to have some rigid parts, people will print, for example, if we're using pliers, people will print the handles and the grip of the head out of PLA or PETG, and then they will print the actual rotating part in TPU so that it flexes back and forth so that you can use the pliers as intended. And there are tons of other examples of that, just using TPU with basically any other material in multi-material printing, because it can really advance the parts that you're making rather than having to, say, printing 3 separate parts and then just kind of hoping to glue them together. You can print it all in place and make sure that it has a really secure bond and not rely on any kind of glue or anything like that, any kind of fasteners to hold parts together. With those different use cases out of the way, I would like to talk about the different ways that multi-material printing can be done. So just first thing that I want to say right off the bat is that it can be done with SLA printing with 2 different vats and the different resin. I don't have any experience in SLA printing, so I don't want to get into it too much, but I just wanted to say that it's popular. But according to my research, multi-material printing is the most advanced in FDM printers. And there are basically 2 different ways that multi-material printing is done. You can either do it through a single printhead, or you could do it through multiple printheads, that being 2 or more. Single printhead is basically just exactly like how a Bamboo Lab printer changes colors. You have 2 different filaments loaded into the printer, and then basically you're going to print out with the one material, and then it's going to stop. You're going to retract the spool of the one material, and you're going to put the new spool in. It just works just like the AMS. You're going to load the new material in, it's going to print on the prime tower, and then you're going to keep going like that, layer by layer by layer. And the downside to that is that it's going to take a long time. I'm sure anybody with a Bamboo Lab printer who has used the AMS system before knows that if you are using multiple colors, especially if you're using multiple colors on the same exact layer, the same goes with multi-material. It's going to take a while because it has to stop every single layer. It has to go through the process of unloading and loading in a new filament, and it has to purge that filament, and it has to go to the prime tower, and then it has to finish printing that layer. So the way to get around that is to get a printer with 2 or more print heads. That's something like the Prusa XL. You can use IDEX, which is independent extruder printers. And basically what you're going to have here is the 2 different materials are going to be loaded into 2 separate nozzles, and the printer is going to take turns printing with each nozzle. And that saves a lot of time because you don't have to essentially waste time unloading and loading new filaments into the same extruder. You can just print whatever on that layer needs to be printed with the one extruder. Then you can move that extruder off to the side, bring the new extruder in with the other filament in there, and then you can start printing with that one. And that makes everything a lot easier, but the downside to that is that these types of printers are much more expensive, often more than double the cost, because apparently double the print heads, or more than double the print heads means double the cost. So that's definitely something to look into and kind of go back and forth if you're looking to seriously get into multi-material printing. Now that we know how to use multi-material printing, I wanted to give some examples of how it's being used, especially in the business world. The number one example that I could find was companies combining TPU, which is the rubber-like filament that I have an episodes on, with carbon fiber filaments to create prosthetics for human beings. And that's something that I find really cool because, first off, I just love when 3D printing is being used in a real case scenario, but being used to help the betterment of human lives is just something that I find really cool and wouldn't be possible without multi-material printing, because they use the TPU for the quote-unquote joint parts that need to move and they need to be flexible. And then for the rigid parts like the leg bone, I don't know what else to call it, but the leg bone part of the prosthetic, they use a carbon fiber, which is really strong and it's not going to break and it's not flexible, it's rigid. And that is just a really nice combination and pretty much the perfect use case for multi-material 3D printing. I've seen and had experience myself in robotics. People will use multi-material 3D printing. They'll use for robotic grippers. For example, if you're using a robot arm and you're using it to pick something up in an assembly line and put it down somewhere else, they will oftentimes have the parts that move be printed in TPU and the actual gripper part of the robotic arm printed in a nice rubbery material, but maybe something firm like carbon fiber so that it doesn't break and it has a stronger grip. And from the research I've done, just trying to think of some examples for beginners in 3D printing and what use cases we might have for multi-material printing, I'm thinking that TPU is going to be the most likely culprit for what we use to combine and to use for multi-material printing. TPU is just the perfect use case to combine with something else because it's flexible and you can use it for a flexible or a rotating type joint. And combining it with another stronger, more rigid material, it's just the perfect combination. It's almost exactly what multi-material 3D printing was made for. So some tips when it or if you are going to try and get into multi-material printing is you need to research on what materials go together, because there are some materials that just do not go together. For me, a perfect example is I tried to combine, not use the PLA and PETG, not use them for the support system like I mentioned. I accidentally combined them into a print when I didn't mean to. I had two different colors, or I had two different rolls of black in my Bamboo Lab AMS. One was PLA, one was PETG. I accidentally picked a PETG to go with my PLA print, and it was a disaster. Nothing stuck to anything, and it resulted in a giant spaghetti mess all over my printer. So that's important to research what materials go together, because just because there are two materials out there on the market does not mean they're going to form a great chemical bond. And you also need to research and design the zipper interlock method, because you can't just essentially butt joint these parts together if you're printing with multi-material. You're better off creating a sort of zipper system where you have a little bit of each material jutting into each other to kind of create a zipper lock so that these materials don't come apart. All right, and with that being said, let's just go over some quick pros and cons. So some pros for multi-material printing is you're going to have greater use cases. It definitely expands your horizon and your outreach for what you can use 3D printing for. You can create better and stronger parts, and parts that are going to be better off being used in the real world. And you can use them in more higher quality fields such as medicine. Some cons is that it definitely is difficult to design. You can't just design it like you're designing a normal single material part. And these parts tend to have a high fail rate just because it's pretty difficult to get these parts perfectly blended together, to get multiple materials perfectly working together. So there is definitely a higher fail rate than usual when it comes to 3D printing with multi-materials. But I'm hoping with this episode that I just created, I hope that I have given you guys some tips and some helpful insight into multi-material printing, and I hope I give you some confidence to be able to try and tackle it on your own, because if you get a hold of multi-material printing, it is something that can really advance the 3D printing journey for you. And with that being said, that is all I have for you today. Thank you so much for listening, and I'll talk to you next time.